Hi students, in this video we will discuss regarding the epsilon used in transportation problems. So first of all, what epsilon is? Epsilon is an artificial rim that we introduce in the equation whenever the rim requirement is not fulfilled. If you remember, we have done in the previous videos that before applying the optimality tests, you have to check the rim requirement with the help of one formula, which was m plus n minus 1. So if the number that we got from the help of this formula is equal to number of rims that we found in the solution, which means the rim requirement is complete. But you will notice that in some question that rim requirement will not be complete. So there we have to introduce an artificial rim which is known as epsilon. That is E, that is in full circle. So what is the value of epsilon to be considered in transportation problems? The value of epsilon will be considered to be something nearest to 0. So you can consider it to be 0 and you can go ahead with the questions. So whenever the rim requirement is not complete, introduce one epsilon in the equation and then you can go ahead with either stepping stone or Modi method. Now let us see one practical question where we will see the rim requirement is not complete and how we move ahead with the optimality tests. Now this is a practical question. It seems to be a normal transportation problem now. Now see, to find out first of all the initial feasible solution, we can make use of any of the three methods, that is lowest cost entry method or northwest corner method or Vogel approximation method. So in this question nothing has been asked, so we can start with Vogel approximation method. So for that we have already done that, we have to calculate the unit penalties. So for calculating unit penalties, we will see minimum and next minimum. So difference of 50 and 30 is 20. Here minimum is 45, next minimum is 90. So difference is 45. Minimum is 50 and 50. So it will be 0. So same way we will calculate UPs below. So here unit penalty 1. Minimum is 50 and 50. So 0. Minimum is 30 and 45. So difference is 15. Here minimum is 50 and 170, so difference is 120. So out of these UPs we have to select the maximum: 20, 45, 0, 0, 15, 120. So 120 is the maximum. We will go inside this and minimum transportation cost is 50. In front of that requirement is 2, availability is 4, so we will give it a 2. It will become 0, it will become 2. So with this this column will be deleted. Next will be again we will calculate UP2. So only 2 columns are left. Of course we will take the difference 20, 45 and it will be 150. Here we will calculate UP2, unit penalty 2 below. For this minimum is 50, 50. Again we will write here 0. This 30 and 45, 50. So now we have to choose the maximum. 0, 15, 20, 45, 150. So of course the highest is 150. We will go inside this row. Minimum is 50 now, right? So in front of that requirement is 3 while availability is 2. So we will put here a 2. So it will become 0, it will become 1. So as it becomes 0, it will be deleted. Next again we will calculate unit penalty 3. So it is 20, it is 45, here it is nil, and below UP3. So this will be unit penalty 3, it will be 40 now and it will be 15 now. So 40, 15, 20 and 45. Highest is 45. We will go inside this row 90 and 45. 45 is minimum. In front of this requirement is 3, availability is 3. So 3, it will also become 0, it will also become 0. So this column is deleted and here this row is deleted, right? So now we are left with only this 50, rest all has been deleted. So here it is 1, requirement is 1, availability is 1. So it will become 0, it will become 0. So now we have reached the optimal solution. Now let us write this solution in a very clear way, the transportation answer. So the transportation cost according to the VAM method, 50 into 1, rupees 50. Then in the first row there is no other rim. So we will come to the second row, and second row this is the rim, 45 into 3. So it will be 15, 1, 135. Next rim we can see is an AZ, 50 into 2, it is 100. Here also ZC, 50 into 2, it is again 100. So these are the rims that we have got. So this total comes out to be 385, right? So now in this question, if it has been told to you to calculate and to apply the optimality tests and to calculate whether the solution that you got is optimal or not. So for that, we can apply stepping stone method, we can apply Modi method. But the point here we have to see is whether the rim requirement is complete or not. So now I will be writing this question, this answer that we have got in a clear format. So this is the solution that we have got. So now to move ahead with the question, we will see whether the rim requirement is complete or not. And we have already done that in case of both the optimality tests, we have to check this rim requirement with the help of this formula. So number of rows in this question were 3, number of columns in this question were 3. So 3 plus 3 minus 1, it comes out to be 5. So how many rims we have got in our answer? 1, 2, 3, 4. So now you can see we require rims to be 5, but in this question the rims we have calculated are 4. So here the rim requirement is not complete. So we have to write one line here. The above solution is degenerate. Till now we were writing the above solution is non-degenerate, but here as the rim requirement is not complete, we will write the above solution is degenerate because the number of stone squares that we have calculated is equal to 4. The number of stone squares we have calculated are 4, while the rims required in case of stone squares are 5. Required stone squares are 5, but actually we have got 4. The required were 5. So it means we cannot move ahead till the time the rim requirement is complete. So what we have to do is we have to make this problem non-degenerate. So you will write, in order to remove this degeneracy, what we are going to do, we are going to introduce one epsilon. How we just write this epsilon is like this, E in the circle. So we have to introduce one. This is like a rim only. We are introducing an artificial rim in the question to complete this rim requirement. So you will be writing, in order to remove the degeneracy, we are assigning E, epsilon, to any of the unoccupied cells. Generally, it is given to the cell which has the minimum transportation cost. So now we will have to see the unoccupied cells where the transportation cost is minimum. This is the first unoccupied cell. Unoccupied cell, unoccupied cell, this is unoccupied, this is unoccupied. So we can see from the question that the cell which is having a minimum transportation cost is this, 30. So what we will do is we will introduce one artificial rim over here like this in order to remove this degeneracy, and we will make it non-degenerate. Another important point you can note down is sometimes epsilon may not be introduced in the minimum transportation cost cell. If it is helping you to make the loops, as we want to do in the stepping stone method, and even in the Modi method we require one loop. So if this epsilon is helping you to make a loop, you can post that epsilon there also. But the general rule says that epsilon should be introduced in the cell that is having the minimum transportation cost, in the unoccupied cell, because occupied cells also already have the rims. So we cannot introduce another rim in the same cell. So we have to observe the unoccupied cell. Wherever the cost is minimum, you can introduce an epsilon to make the problem not degenerate. Now this has become our final answer. We will check now the optimality test on this table now. So now in this question, in order to have a simplification, I am going ahead with the Modi method. Now if you remember, for the Modi method we have to just post here R1, R2, R3 and above K1, K2, K3. Let's write that. So now we will give here name R1. This is my row number 1. This is row number 2 and this is row number 3. And above we will give the name column number 1. This is column number 2 and this is column number 3. So first of all we have to start with the occupied cells, as we have already done. So let us take the occupied cells. So our first occupied cell is this AX, right? So this cell has been become with R1 and K1 and its value will be taken to be this. So we will write here R1 plus K1 is equals to 50, right? Second occupied cell, now this has become an occupied cell. R1 K2 is equal to 30. R1 plus K2 is equals to 30. This is unoccupied, this is unoccupied, this is occupied, that is YB. R2 plus K2 is equal to 45. R2 plus K2 is equals to 45. This is unoccupied, this is occupied, AZ. So R3 plus K1 is equals to 50. Next, this is unoccupied, this is occupied, that is ZC cell. We will write R3 plus K3. This comes out to be 50, right? So from here now we will calculate the values. Now as we have already done, you can take any of them to be 0. So I am letting R1 to be 0. If R1 is 0, K1 will be 50, right? If R1 is 0, K2 will be 30. If K2 is 30, R2 will be 15, right? K1 we have already calculated 50. So R3 will be coming out to be 0. If R3 is 0, K3 will come out to be 50. So like this, we will calculate all the values. So R1 is 0. R2 has come out to be 15 now. R3, it has also come out to be 0. K1, it has come out to be 50. K2, it has been calculated as 30. And K3 has come out to be 50. So now all the values we have got. So now from here we will calculate the values of unoccupied cells now. This we have done for the occupied cells. From the occupied cells we have calculated these values. Now we will do this task for the unoccupied cell to calculate the opportunity cost. Now let us take the unoccupied cells for this purpose. We are calculating their opportunity cost now. So now we have to identify which one are the unoccupied cell. This is occupied, this is occupied, this is my first unoccupied cell, that is XC. For calculating the opportunity cost of XC, this will be 220 minus 0 minus 50. So 220 minus 0 minus 50. So it will come out to be 170. Second cell that I can see which is unoccupied is YA. We can write AY or YA. Its value will be 90 minus 15 minus 50. So 90 minus 15 and minus 50. So this will come out to be 25. So like this we will calculate the opportunity cost for every unoccupied cell. This is occupied, this is unoccupied now, YC. So for YC it will be 170 minus 15 and minus 50. So it will be 105. And the next unoccupied cell is this, I can see ZB. So for calculating opportunity cost of ZB, it will be 200 minus 0 minus 30. So it comes out to be 170. Now as we can see, opportunity cost for every unoccupied cell comes out to be positive. So all the values are positive. It means we have already reached at the stage where the transportation cost is minimum and it cannot be reduced further. It means this answer 50 into 1, 45 into 3, 50 into 2, 50 into 2 that we just earlier calculated and the total cost came out to be 385. That was the minimum transportation cost. You have to write that solution again. Now for 30 into E, that is epsilon, the value of epsilon is generally considered to be something near 0. So you need not show it, or you can show it to be 0 because this is an artificial rim. So it will not lead to any increased cost. Just for the sake of calculating, we have introduced this. So our final answer will be same that we have already calculated, rupees 385. So this is how you can solve the problems when the problem is degenerate, and you can introduce epsilon. In some question, more than one epsilon may be asked to be introduced, and the calculation part is going to be the same. Just remember this thing, that the value of epsilon is considered to be something nearest to 0.